Okay, so last time we were talking about normal distributions, and we said that using just a little bit of knowledge about our data, we can find some very specific locations for that data. So for instance, if we have a normal distributed data, okay, that's pretty terrible. I'm going to start that again. So if we have normally distributed data, something like this, what this represents is frequency. So these shorter parts of our curve are data points that have very little frequency. Maybe they only happen once or twice in our data set. And then, of course, this peak means that this is where we have a data point that occurs more than any of the others. In other words, our mode. Okay. Now, because this is normally distributed, this is a symmetrical set of data. So we have very little frequency here. It's the exact same on this other side. These are perfectly the same. They're perfectly symmetrical. So we can also say that this center line where our mode is cuts our data in half perfectly, where 50% is on this side and 50% is on this side, meaning that this is also the median, the middle of our data. Okay? And if it's normally distributed, that means that the mode, median, and mean are all centered on the same point. Okay. So what we were talking about specifically was finding the percent of data that is within a certain area of this frequency distribution. So for instance, maybe this is data for ages of people in retirement homes. All right, so perhaps our average age for a person in the retirement home is 70. Seems about right to me anyway. And we have a standard deviation of 10 years. Okay, so the average person is 70, but then the standard deviation for this set of data is 10 years of age. And this point right here is maybe 50 years. So something that we could do is figure out how many people, or what percent of the people in this retirement home are at or below the age of 50. Okay, so what we would be doing is finding this area right here. How many people, or what percent of the people fall in this area? Okay, just to organize our data a little bit more, mean mu is 70, and then our x, we want to find this part right here, which would be x is less than or equal to 50. So again, x is less than or equal to 50. All right. So to do this, what we need is a z-score. And a z-score is calculated by taking z equals x minus the mean, mu, over our standard deviation, 10. Oh, shit. That's not what I meant to do. Z equals x minus the mean, mu, over sigma, standard deviation. Okay, so this is our formula. Any point that we're looking at any given time is going to be our x, then the mu is mean, and sigma is standard deviation. So we can plug these numbers in. Z equals 50, the x that we're looking at right now, minus the mean, 70, divided by the standard deviation, 10. Okay, so 50 minus 70 is negative 20. So z equals negative 20 over 10. And then negative 20 divided by 10, that means that we have a z of negative 2. Now what the z-score does, it relates where this point is on what kind of curve we have. Because this curve could be really shallow, it could be really steep. This curve could have all sorts of different shapes, just as long as it is only got one peak and it is symmetrical. So this standard deviation kind of relates the distance this is from the mean to the rest of the curve. So this z-score now can give us our probability if we look up the z-score on our z-table. So the first page right here is positive z-scores, but as we can see here, we got a negative z-score, so we need to go to the next page. And there's our negative z-scores. So we look up negative 2, let's see, so scroll down here until we get to negative 2. And then the next digit, well, there isn't another next digit, so we just go over to 0. So negative 2, 0. And we have a probability of 0.02275. So because of this z-score, we can see that we have a probability of 0.02275. Now what this means is if we picked somebody in this retirement home at random, there is a 2.275% chance that they're going to fall in this group. Another way of wording this is that 2.275% of people in the retirement home are at or below the age of 50. Which makes sense. Not a whole lot of people would be younger than 50 and be in the retirement home. Does this make sense? Yeah. Okay, good, good. All right. So that's one thing that we learned how to do Wednesday. Another thing was, well, what if we don't want to find below a point? So both of these z tables, well, they calculate below a certain point. But what we want to do is we want to calculate not below, but above. Maybe we want to know how many or what percent of people in the retirement home are above the age of 50. Okay, well, to do that, we first need to remember that this curve is a representative of probabilities. So, like, for instance, this part right here is a probability of 0.02275. But if we added up all the pieces and parts of this, all the probabilities of this curve, they would equal to 1. So the entire thing altogether is 1. So what we can do then is say, all right, if we want to find not below but above, we can just take the same probability that we just found, we know that represents this, and subtract it from the entire thing. In other words, 1 minus this probability will give us the area above that point instead of below. So let's go ahead and see what that is. 1 minus 0.02275 is 0.97725. Okay. So yeah, below 50, we got about 2.2%. Above 50, so using that same probability, just subtracting it for 1 to kind of flip it over to this side, we can see that 97.725% of people in the retirement home are above the age of 50. Again, that makes sense. Any questions? No? Okay, good. Okay, so again, that's what we learned last time. We learned how to calculate below and above. And they're done the exact same way. Just whatever x you have, plug it into that equation and get your probability. Now that will always give you the one that's below, so if you're looking for above, just take that extra step and subtract it from 1 to get your probability above. So I posed the question last time, well, if we can calculate below and above, can we calculate in between? So something like this. And the answer is absolutely. We have the tools that we need. All we need to do is kind of rearrange how we use them to figure out just this part in between. Okay, so let's try that out real quick. In fact, let's use the same numbers. So still, mean of 70, and maybe this is also 50, but this one right here is 45. Okay, so what we're going to do now is, instead of looking for, okay, what percent is below 50 or above 50, we're going to be looking for what percent of people are between the ages of 45 and 50. Okay? Well, that means that we have two x values. Our sigma, our standard deviation, is still 10. Our mean, mu, is still 70. But we have what we want to calculate is what is our x if we want to be between 45 and 50. We have two x values. So that means we're going to have to calculate two different z-scores. So our first z-score is going to find this right here. Okay? So this is going to be, let's call it Z1. So we have 45 for our x value, minus our mean, 70, divided by our standard deviation, 10. So let's see what we get for that one. So 45 minus 70, and then divide by 10, we get negative 2.5. Okay? Now again, what this represents is not what's in between, not what we want. This right here, if we look up its probability, is going to give us this part. Let's go ahead and look up that probability so we know what this part is. So again, it's a negative z-score. And so we scroll through until we get to negative 2.5. And then again, nothing comes after that, so we're on this first column here. And we have a probability of 0.00621. Okay. So then we have this second x value. And remember, when we do our z-score, it's going to calculate behind. So there's going to be some overlap here, right? So it's going to calculate all of this and all the way to here. So let's go ahead and do that. We'll call it z2. And it's 50 minus 70 over 10. Well, we've actually already done this up here. We know what it is. Z2 is negative 2. So we look up that probability. And the probability for 50, so the probability that something's going to be in this entire area back behind 50, is 0.02275. Okay, now remember, again, like I said, these overlap. So this one is just this part. This one is the entire part back behind 50. So we haven't calculated any of this, right? I mean, we don't need it. We just want this part. We have calculated this. It's this. What if we subtracted that from what we have here? So remember, this right here is this entire part back here. So if we subtract this part, it just gets rid of that and gives us what's in between. Make sense? Okay. So we can subtract these two. So subtract P1 from P2, and it should give us the area in between. So let's see here. 0.02275 minus 0.00621 gives us the final probability of 0.01654. Or, as a percent, of course we can change any probability to a percent, this would be 1.654%. So just above 1% of all of the people in this retirement home are in this range, between 45 and 50 years old. Make sense? Okay. Any questions? All right. Well, That didn't take very much time. We have one more thing I want to go over today. And so this is from me looking through Hawks and seeing what y'all needed to do, and Hawks gave me this question. Okay. So we've seen how to go from an x value to a probability. So calculate the probability of something landing behind an x value or in front of an x value. What if instead of getting an x value, we're given the probability? So this frequency distribution here, let's say that this area right here represents a probability of 0.99224. So we know the probability of a data point being in this area. 99.224% of our data is in this area. But what's this point here? Where is it stopping? Well, this would be an x, just some data point that we have in our set, but we don't know. We don't know what the x is. Maybe we want to find that x. Now, this is all the information that Hawks is going to give you. If you want to find the exact value of that x, you're going to need to know the standard deviation and the mean. Hawks is not going to give that to you because what they want you to do instead of finding an exact value for x is to find an equation for x. Okay? So, let's think about this real quick. Again, we know how to go from x to a probability. We take the x, put it into our formula, get a z-score. That z-score gives us a probability. So, it stands to reason that we could probably just do the opposite if we want to go from a probability to an x. So take our probability, look it up for a z-score, put that z-score into our formula, and find x. Exactly the opposite of what we've been doing this whole time. So let's look at our table. Well, here I'm on the negative z-scores. And if you notice, all of these are very small. We go from a 50% probability to the smallest one, which is a 0.002 probability. So 99% is nowhere on here. And that's because, well, again, we have an x that is larger than our mean. So these large probabilities, they're always going to be in our positive z-table. So if you have a very small probability that you're looking for, go to your negative z-table. If you have a really large probability you're looking for, go to your positive z-table. Okay, so now we need to look for 0.99224. So let's find where it starts at 0.99. I see it at 0.99286. That's too high. We need to go back a little bit. So this is 0.99266, 0.99245, getting closer. Right there. 0.99224 is right there. So then we just look and see, all right, what digits does this line up with? We got 2.4, and the next one is 2. So altogether, our z-score is 2.42. Okay. Now the only way we know to relate this z-score to an x is with our z formula. Again, x minus mu over sigma. So if we want to find x, what we're going to need to do is take this number, this z-score we found, and plug it in for z. So we have 2.42 equals x minus mu over sigma. With me so far? Okay. All right, well, again, we want to find x, which means we need to solve for x. In other words, get x by itself in this equation. All right, well, fractions suck, don't they? So let's try to get rid of this fraction first, because it's making it hard to solve this thing. We're dividing by sigma right now. That's what's making this fraction. So what would be the opposite of that? How would we cancel it? Yeah, multiply by sigma. And of course, we need to do that on both sides. So here, since we're multiplying and dividing by sigma at the same time, they cancel, leaving us with x minus mu. And then on this side, we have sigma times 2.42. Well, the best we can do with that is 2.42 sigma. All right, well, we're getting close. And we want x by itself, but right now we have x minus mu. So how do we get rid of mu? Well, what's the opposite of minus mu? Yeah, plus mu. So plus mu to both sides. That will cancel here since these are opposites. And on this side we have 2.42 sigma plus mu equals x. And there we go. X is now solved for. This is what Hawks will be looking for. This equation right here. So again, if we want to know the exact value of x in this case, we're also going to need to know our standard deviation, which is sigma, and our mean, which is mu. But because we don't have those in this case, the best we can do is get an equation. Any questions? Okay. It's just as long as it makes sense. So next week, remember that Wednesday is a holiday, so we won't have class on Wednesday of next week. I got that right. Check my calendar real quick. Yes, next week. But do expect a quiz next week. So obviously you can't be on Wednesday, and it would be evil to give it on Monday. So quiz on Friday. All right, but that is all I have for today. You get to go real early. And I hope you have a great weekend. I'll see you on Monday.